now in section 6.2, homework help. As always, if something that you should be looking up or you should have learned from the lecture, I'm not going to help you with the homework, all right? And so let's turn that off, the answers. A binomial experiment is performed a fixed number of times. What is each repetition of the experiment called? Okay, just read the book or look at the lecture. In the binomial probability distribution, the combination NCX represents the number of ways of obtaining X successes in N trials. Again, you should look that up. What is the formula for the expected number of successes in a binomial experiment with N trials with probability P? Remember, expected value and mu are the same thing. Okay, expected value and the mean of the distribution. So look that up. Now this is interesting. Some of these are a little bit confusing, but determine if the following probability experiment represents a binomial experiment. So you have a random sample of 80 middle school students. Okay, so that's going to be your 80 fixed trials. And the individuals are selected and asked to state their heights. Now the reason this is not binomial is because you don't have just two mutually exclusive outcomes, because their heights are going to be a lot of different things. And the variable is continuous because it's heights. Determine whether this is a binomial probability experiment. Experimental drug is administered to 40 randomly selected individuals. This is going to be your fixed number of trials, okay, with the number of individuals responding favorably recorded. This is a binomial experiment, okay. Remember, there's 4 criteria. 2 mutually exclusive outcomes. Now they're going to respond favorably or not. Okay, fixed number of trials. This is the 40. Okay. All the trials are independent. That's because they're randomly selecting these people out of the population. Okay. And the probability of success is fixed. It doesn't say that, but it's implicit. Determine whether the following probability. Now this one's not, because what you have is you're selecting 7 cards, but we don't have replacement, so the trials are not independent. Right? What you get on the first pull affects what gets on the second, because you're pulling 7 cards out of 52 without replacement, and so you lack the independence of trials. Now, this one is not, because you don't have a fixed number of trials. He's going to keep shooting until he gives up one goal. Okay, because the experiment is not performed a fixed number of times. He stops 88% of his goals and is asked to make saves until he gives up one goal. All right, until is the key here. There's not a fixed number of trials. So here we have a fixed number of trials of 10 stocks. We're going to investigate whether they go up or down. The probability of success is fixed at 46%. Okay. Now, when it says randomly purchased, because it's random, we're going to assume there's no effect between the stocks. There's no connection between these 10 different stocks we choose. And so this random selection guarantees our independence of trials. Okay. So we have just 2 mutually exclusive outcomes, up or down. Probability of success is fixed, a fixed number of trials, and the trials are independent. So now you're going to do this using technology. Okay. If you're taking this class from me where we have tests or quizzes in class, then there's a very high degree of probability that you'll be asked to do this by hand. But in the homework, it's all going to be done using StatCrunch. Notice here, there's not a data set that we can export to StatCrunch. And so what we're going to do is go to Question Help, open StatCrunch there. And so we go to Stat Calculators Binomial, Stat Calculators Binomial, open that up. And now we either want standard or between. And so in this particular case, we want equals 3. So use standard. Standard is for everything less than or equal, greater than or equal, less than, greater than, or equal. And use between if it's between 2 numbers. Okay. So go back to standard, choose equals, give it in the problem, see right there, equals. choose n equals 10 and p equals 0.35, hit compute, and you get the answer 0.2522. Leave that open. Go to the next problem. N equals 50. P equals 0.04. And x equals 2. Compute. Notice we have the answer. To do this one, you just choose less than or equals. Okay, adjust the numbers. Less than or equals. So now this is a little bit more difficult. Again, leave the StatCrunch open. You're going to, according to an airline, flights on a certain route are on time 80% of the time. That's your fixed probability of success. Suppose you have 13 flights. That's your fixed number of trials. They're randomly selected, so there's no influence between the different flights, and so that's your independence. All right, and the number of on-time flights is recorded, so it's either on time or not on time. That's your two mutually exclusive outcomes. Find the probability that exactly 8 flights are on time. Just go over here to the calculator, adjust the numbers, and compute. The interpretation is, in 100 trials of this experiment, it's expected that about 7 result in exactly 8 flights being on time. What they're talking about here is this probability that you computed in part B is approximately 7%, rounded off to whole percent. Now I want to talk about what a trial is. In this particular binomial experiment, so if you look at 13 flights, and so if you do this 100 times, you're actually looking at 1,300 different flights, 100 groups of 13. About 7% of the time, you should see exactly 8 flights being on time. And so because the probability from part B was 7%, you should expect to see exactly 8 out of the 13 flights being on time, about 7 times out of 100. Fewer than 8, that's a less than. Interpret this probability. Okay. Find the probability at least 8 flights are on time. At least means greater than or equal. Interpret the probability. Now, do you see where it says between 6 and 8 exclusive? That's going to be between over here on the calculator. I don't know if you'll get this particular question. It's interesting. It's about sort of discrimination. So you have 14 jurors. They're randomly selected. That's going to give you your independence of trials. Okay, the 14 is your fixed number of trials. And from a population of 4 million residents. Of these 4 million residents, it's known that 39% are of a minority race. Okay. Of the 14 jurors selected, 2 are minorities. So the proportion of the jury described that is from a minority race is 0.14. How did I get that? Okay. 2 divided by 14. 2 divided by 14. Now, find the probability that 2 or few out of the 14 are minorities, assuming that the overall proportion of minorities in the population is 39%. So they're asking, what's the probability of only getting 2 minorities out of 14 jurors if the true population proportion is 39%? The answer is less than 5% in this particular case, and so that's unusual. And so the answer down below is the number of minorities on the jury is unusually low, given the composition of the population from which it comes from. This composition of the population is referring to the 39% minority. So here they want you to look at the mean. Remember, the mean is NP. They want you to look at the standard deviation. Remember, that's the square root of NPQ. Let's talk about that. This right here is the formula for computing the binomial probability by hand. You should be able to do that. All right. This NCX is the number of ways you can arrange your successes and failures. P is the probability of success, and so X is the number of successes. 1 minus P, because there's only 2 mutually exclusive outcomes. That's the law of the complement. That's the probability of failure. And this N minus X is the number of failures. So if you have 10 trials and 7 successes, you're going to have 10 minus 7, 3 failures. This is the formula for the mean. This is the formula for the standard deviation. Another thing that's going to be important in this particular problem is this idea that if NPQ is greater or equal to 10, then the histogram for the binomial distribution, is going to look relatively bell-shaped. And as we learned from the empirical rule, okay, that whenever you have a bell-shaped symmetric distribution, then you should expect to see about 95% of the data, what we call usual, because we remember we use 5% as a threshold for unusual, between -2 standard deviations and +2 standard deviations. Okay, so you're going to have to think about this before you do this next problem. Whenever the binomial distribution has NPQ greater or equal to 10, its histogram is relatively bell-shaped and symmetric, and we can use approximation using the empirical rule. And remember, you get the middle or the usual 95% between plus or minus 2 standard deviations around the mean. So we compute the mean, NP, we compute the standard deviation, NPQ, and we also notice that NPQ is greater or equal to 10. And so would it be unusual to observe 180 smokers, okay, who started smoking before they turned 18, in this random sample of 200? Well, we compute mu plus 2 standard deviations and mu minus 2 standard deviations, and notice this 180 falls outside, falls higher than 2 standard deviations above, and so it's in the area we call unusual. You can look this up, talk about that, look that up. We just talked about that a moment ago. And again, we just talked about that a moment ago, but pause, think about that a little bit.